The last section we cover in Chapter 7 is Section 8, and it's called Multiplying Special Cases. So by the end of this lesson, you want to be able to multiply polynomials of special cases. We're still going to use the FOIL method. Remember, FOIL stands for first, outside, inside, last. And those are the terms that you multiply together. Essentially, you're multiplying everything in the first parentheses by everything in the second parentheses. So let's simplify the product. We did talk about one of these in class a few days ago, where when you have a quantity that's being squared, it means you have two of those quantities, in this case t plus 6, being multiplied together. So we want to FOIL. T times t is t squared. T times 6, 6t. 6 times t, 6t. And 6 times 6 is 36. Again, we always need to combine the inside and outside terms, or the like terms, whenever we can, to get t squared plus 12t plus 36. And I want to talk for a minute about why this is considered a special case. This is considered a special case because the two binomials are identical. So you can see that your first term ends up being the t's squared, and your last term ends up being the 6 squared, and your middle term is essentially a 6t doubled, or times 2. So let's try to remember that as we go through some of these. Number 2, we have 5y plus 1 quantity squared. So remember again, that's 2 5y plus 1s multiplied together. So we have 5y times 5y. Remember, multiply the coefficients, 25, and add the exponents, 25y squared. The outside term, 5y times 1, is 5y. The inside term, 1 times 5y, is also 5y. And then the last is 1 times 1, which is just 1. Again, we need to combine the two like terms to get 25y squared plus 10y plus 1. So if we look at the pattern we saw in the last example, the first term ends up being this first term squared, 5y squared. The last term ends up being 1 squared. And the middle term, if you multiply these two together, it's 5y times 2. 5y times 1 is 5y. Multiplied by 2 gives us 10y. So it's essentially that 5y doubled. Let's try one that's a little more complicated, but still is going to follow that same pattern. Remember, when it's a quantity squared, we have two of them being multiplied together. So 7m minus 2p times 7m minus 2p. So we're going to do our first. For 7m times 7m is 49m squared. Our outside terms, be kind of careful here. It's 7m times 2p. Those variables are not the same, but we do need to multiply the coefficient. And notice this one is a negative 2p, so it should be a negative 14mp. And typically when we write more than one variable, we do write them in alphabetical order. Our inside term, the negative 2p times 7m, should give us another minus 14mp. And when we multiply the last two terms together, negative 2p times negative 2p is a positive 4p squared. Again, multiplying coefficients and adding exponents. Notice we do have like terms in the middle. Like terms have the same variables with the same exponents. We have an m to the first and a p to the first. So we have 49m squared minus 28mp plus 4p squared. Now again, these were identical binomials we were multiplying, so notice 7m squared is 49m squared. The negative 2p squared is the positive 4p squared. And if you multiply these together, you get a negative 14mp, and if you multiply it by 2, there's that middle term. So there's kind of a pattern when we're multiplying identical binomials together. Now let's talk about the last type of special case, And this is when we have identical binomials, but our sign in the middle is opposite. So I have d plus 11 and d minus 11. We're still going to FOIL, so d times d, that's d squared. That's f for our first term. Our outside terms, d times negative 11 is minus 11d. Our inside terms, positive 11 times d is plus 11d. And our last 11 times negative 11 is negative 121. Now we need to combine our two like terms. So we get d squared. If I have positive 11d and if I have negative 11d and I add 11d, those two cancel. I'm not left with any d's. So then I have to bring along the minus 121. So let's look at what's happened here. This is the first time we've seen this. When you have binomials that are identical, but they have opposite signs in the middle, this middle term is actually going to fall out. It's going to drop away because they cancel each other out. You end up with positive 11d and negative 11d. So let's look at another example. C squared plus 8 times c squared minus 8. We want to do our first. C squared times c squared is c to the 4th, adding exponents when we multiply. Our outside term, we get a negative 8c squared, and our inside term gives us a positive 8c squared. Our last term gives us negative 64. So again, combining the like terms, negative 8c, positive 8c, those cancel each other out. So we're just left with c to the 4th minus 64. What you'll also notice in this special case is that your last number, this back term, the constant, will always be negative because it will be a positive times the negative. And if you go back and look at 4, you can see that it was negative 121. Let's do this last example on your own. This one's, again, a little complicated because we have two different variables in the front and the back of the binomial. But notice that the binomials are identical with the exception of the sign in the middle. So think about the pattern that you should see or the type of answer you should get. So pause the video here and then check your answer. So 9v cubed times 9v cubed is 81 v to the 6th. We have our outside 9v cubed times a negative w to the 4th. We get negative 9 v cubed w to the 4th. Inside, w to the 4th times 9v cubed. Another positive 9v cubed w to the 4th. Remember, in multiplication, we can write it in any order. We typically write the constant first, followed by the variables in alphabetical order. It's also a lot easier to see now that we're going to have like terms here. If you had written w to the 4th 9v cubed, it's not as easy to tell that these two are like terms because this is written in a funny order. So try to keep that habit of writing the constant, then alphabetical order. Finally, our last term gives us a negative because it's a positive times a negative. W to the 4th times w to the 4th is w to the 8th. Make sure you're adding your exponents. Again, in the inside, our terms are going to cancel. So we end up with 81 v to the 6th minus w to the 8th. Hopefully you got that one right. If not, you can see where you went wrong and fix your answer. We have two more examples here, and what I want you to do is try to work these examples out on your own, and then we're going to talk about them in class. So you're not going to see the answer here. This will be another way for me to know if you're actually listening to the video or not. So we have number 7 where it says Mr. Hill is putting in a swimming pool. Find the area of the concrete that is needed to surround the pool. And you can see the concrete here is this lighter gray, the pool here in the middle in blue. So I want you to try this example, and I'll be checking it in class. Also, I want you to do number 8. This one says write a polynomial that represents the area of the entire figure. So we have two that are connected here, but I want the area of the whole thing, and you can see the dimensions. So this one also needs completed for class tomorrow. So are you able to multiply polynomials with special cases? Remember what we talked about. We have two identical polynomials multiplying together, or identical polynomials with opposite signs. Those are the two types of special cases we talked about today. Examples 1 through 8 essentially hit on that idea. And we'll work on worksheet 7-8 in class.